people that also want to tune in on this online. So for those who are watching online, welcome. For those who are here live with me, you're in luck because over the course of the next 1.5 hours, my focus is getting as much value as possible that I can transfer. As I was sharing with the class earlier, because there's a lot of questions that I've prepared, like 30 pages per TYS highlight. So we're looking at like 60 pages of questions. It is impossible for me to cover everything in depth, meaning like I go through every single solution, every single working step. Anyway, this session is meant for Sec 4s. They are taking your O level tomorrow already. So cannot be every single thing you don't know, right? So you should at least have a baseline of understanding. Today is the chance for me to help you avoid making careless mistakes that tend to happen because of either due to a lack of understanding or conceptually you just have a bit of misconception that might cause you to make these mistakes tomorrow. So earlier I already did a poll on like roughly what are the topics you're weaker at. So I'll try my best to spend more time on those topics. Now, along the way, if there's any technical issues, let me know. It's not on YouTube because today I didn't hit the capacity. Last week cost too many people, so I had to live stream on YouTube. Otherwise, I think for those of you who are on the Zoom session, you can just tune in here. I promise to upload the recording once it's done processing on YouTube as well. Okay, so you guys can review this again. Once again, if you're wondering where is this document, can you download this or not? Unfortunately, the answer is no. I'm not going to be uploading this because today's session was meant to be a free lesson for my own students as I go through with them a worksheet that I prepared for them. But I was like, YOLO, guys, we are taking O level tomorrow. Let's just do this together. Therefore, I decided to open this session up to the members of the public. Therefore, this is actually our own internal group tuition stuff. Okay. But don't worry because every single question that you see can be found in the TYS. So as long as you have your yearly TYS with you, you will see the question as is and you'll still be able to follow through. Okay, without further ado, let's jump straight in. Let's tackle as much as we can. There are a lot of important things I have to share with you all the night before your exam. Okay, the first question we're looking at is from the 2016 paper. This is paper 2, question 1. Now, question 1 typically is usually kinematics. Otherwise, it jumps straight into a dynamics question with vector or calculation. So for you to see a kinematics question as your question 1 is not surprising at all. Now, this is one of my worst fear. All right, now the situation that we see over here is that it happens this crazy guy that's always standing by the cliff, throwing a ball up, and due to gravity, the ball comes down. Now, I want you to focus on the word here, and the word is acceleration. Now, I know I've reviewed the answer already, but I'm very certain that most of you, if you're doing this question fresh or for the first time or in a while, a lot of you will not get the answer. Why? Many of us have the misconception and we are not able to differentiate the difference between velocity and acceleration. Now, the question here is acceleration. Regardless of where the ball is at the hand as it's going up, at the highest point or when it's coming down, from start to finish, the only thing acting on the ball is due to gravity. In other words, the only acceleration happening to the ball is the acceleration of free fall. And acceleration of free fall always have a fixed magnitude of 10 and the direction of gravity is always downwards. So it doesn't really matter whether the ball is moving upwards at the highest point of motion or even when it's moving down. I know velocity changes, right? Because when it hits the highest point is zero, velocity increases as it's coming down, sure. But the word here is velocity. So velocity changes, but your acceleration of free fall is constant throughout. With that being said, take note, this entire scenario is calculated based on the fact that air resistance is very small, meaning it's negligible. So if air resistance is negligible, the only force that's acting on the object is gravity. Therefore, magnitude will be 10, direction will be downwards. If we introduce air resistance, then the question will be a little bit different. It usually pans towards terminal velocity. In summary, for question 1, please understand acceleration or free fall for gravity does not change. Okay. Let me check. I think I'm lagging. Okay. Um, bear with me for a moment. Let me change my Wi-Fi to see if my connection improves. Okay. Let me know if I'm still lagging afterwards. Connection issues. All right, people, I'm back. Is this less laggy or laggy? Can I have some response? Thank you. But thanks for letting me know if it's laggy, because it does affect your learning experience. How? No lag already, So okay, Okay, can. Yes, this one's only the weight. Take note, I'll try to answer as much of your questions as possible, but please understand if I'm not able to answer all of your questions. Okay, it's better already. Nice. Thanks. Okay, now part B, right? I want you all to pay close attention to this. I think this graph here is very important as it's a very common velocity time graph that they usually ask you to sketch. Now, one thing I want you all to notice about this graph is that it is a straight line. Now, why is it a straight line so important? First thing you already need to know is that a velocity time graph, what does the gradient give us? The gradient give us acceleration. And why is acceleration here constant? It is constant because my acceleration of free fall is a constant value. So if you actually took time to calculate the gradient of this graph itself, you will calculate and it will give you exactly a value of 10 because acceleration of free fall is 10 ms minus 2. So if you're wondering, hey, how do I plot my velocity time graph? I always don't get it. Just remember this. Your gradient is your acceleration. Okay, everything else is not important. Now, the other point that is worthy to note, right, is here. If your velocity is 0, this will always be at your highest point. Meaning, as my ball is moving up and down, I'm talking about this point over here. So when you're here, it's almost like you're momentarily at rest. I'm like stationary for just that moment before I go down. Okay, so these are certain clues that you can use to help yourself get your velocity time graph right. All right, and with that, I think this is the key points that I'm trying to highlight here. And in usually expect a kinematics question. This is also the reason why we want to go through a few more that I think y'all might be weak at. Now, this is another good question for kinematics. This is from the 2015 paper. All right, this is in your paper 2, I believe, question 10. Now, we have this skier going down the slope. There are different timestamps, and at different points, they call it A, B, C, D. Now, you can obviously use the timings to plot roughly where you'll be on the graph. So, one very important thing that I would like to highlight to you guys is this. Notice between A and C, they say acceleration is uniform. So if that is the case, what should the gradient be like between A and C for the first 4 seconds? We always expect it to be constant. Because for velocity time graph, what does the gradient give us? It gives us acceleration. So over here, a constant gradient means it's a constant acceleration. So acceleration is uniform. Okay, then after D, we see over here that the velocity is constant again. So this is velocity is constant. It's different from acceleration. So over here after D, this is how the graph should look. Okay? So all I'm asking you guys to do is just to be very conscious whenever you're dealing with velocity time graph thing. Am I thinking of velocity or am I thinking of acceleration? All right. Now, for those of you who have just finished your AMF paper, if you think about it carefully, distance time graph is y and x, right? Velocity time graph is dy dx. Acceleration time is therefore d2y dx squared. So you can also use that understanding to make sure that you get your graphing right for kinematics. Okay, so that is just one point I'd like to highlight. One very common thing that they'll ask you to do is to calculate the area underneath the graph. So for velocity time graph, area underneath the graph gives you distance. All right, just for this one, right, I want to highlight this point. Now, the distance between point A and B, this is easy lah, right? Because A and B is just this area over here. But my worry is between B and C, right? Can y'all not make the mistake and recognize that it is this area of this, was it trapezium, instead of the entire area of the triangle? So it's between 2 to 4 only. So it's only this area. Can? All right. I know a lot of you probably already know this, but I just want to be very careful. All right. So distance between B and C, that's why the calculation over here you see calculates the area of a trapezium. So just be careful for that. One of the things that could happen is that they might give you a velocity time graph. They ask you to sketch out displacement time, as you can see over here. So let me ask you a very simple question. If it's a displacement time graph, what is the gradient? What does the gradient give us? The gradient gives us velocity. And we have acknowledged from point D onwards, velocity is constant. So from point D onwards, velocity should be a straight line. All right. And in the initial part, as it's accelerating, you can see that if I draw a tangent, you can clearly see that the gradient is increasing over time. So that's how we know that the velocity is increasing over time. All right, so that's all for these two questions. I'll say the key things for y'all to take care of is really just making sure that you are very, very clear when it comes to velocity versus acceleration. Otherwise, it will be very painful for you tomorrow. Okay, I am expecting kinematics to appear tomorrow. If it doesn't, I cannot predict what will come out, lah, but it's just based on trend. Okay, you must be ready. And if this is something you're not confident in, please go and revise again. All right, just based on the number of times you have came out recently for your kinematics, you have to be prepared for it. Okay, next. For question 3 itself, this is typically one of those that are quite confusing. Now, let me be very, very clear here. When you are looking at this man and they're saying that, hey, draw and label the forces on the man. Sure, most of you understand if he has a mass, there's a weight downwards. And if he's standing on a surface, there's a normal reaction force from the floor onto the man. Right? Now, we take a look at figure 3.2. Figure 3.2 is very interesting. Why? There is no gravitational field. So if there's no gravitational field, there shouldn't be any weight. All right, that's why you see when we label, we do not label the weight of the man. All that's left on the man is just the normal reaction force of the lift on the man. Now, with all of that being said, please recognize this, that weight and normal reaction force, while they might be equal and opposite, that does not mean that they are action-reaction pair. Repeat one time. I know here that the weight and the normal reaction force can be equal and opposite. They sort of like cancel each other out. But that doesn't mean that you conclude that it's an action-reaction pair. For it to be an action-reaction pair, they have to be the same type of force acting on two bodies. What do I mean? Let's take a look at the answer in part B. Read with me. For figure 3.2, the weight of the man is due to Earth's gravitational field. Meaning, right, if you're using the word weight, the two bodies that are in action is between the man and Earth. So the action-reaction pair should be between man and Earth and man. All right. And if you're talking about normal reaction force, it is between the man and the leaf floor and man. So let me conclude this and let me be clear once again. Labeling of these two forces, no problem. But please do not just assume that because it is opposite in direction means they are action-reaction pair. Clear? Okay, so this could be one of the biggest mistake that you guys will be making because for it to be an action-reaction pair, I see a question on why. Let me address this quickly. Because I know if I don't address this properly, a lot of you have this misconception. You know why? Because when I took my own O level, my teacher didn't explain this clearly. So I had that misconception myself. So let me be quick on this. So when we say Newton's third law, right, if you want to be an action-reaction pairing, right, you must be the same type of force. You must act in opposite direction on different bodies. So what this means, right, is that if you want an action-reaction pair, it is either you use the word weight, whereby it's an interaction between book and earth, or you use normal reaction, which is between the object and the surface and the object. Can you see the pairing is always A on B, B on A on B, B on A. Which is why, if you go back to this question, the weight, right, is between man and earth. The normal reaction is between the man and the lift. So you cannot say that the weight and the normal reaction force is an action-reaction pair. Now, I know that is not what the question is asking for here, but there are other questions that have appeared in O-level before that ask us to identify the action-reaction pair. And if you write weight and normal reaction is confirmed wrong. Okay, so to answer part B, yes, this answer is fine. All right, but please don't mistaken how an action reaction pair work. If you're not clear, please go back to the curated notes or your textbook to go and reread through this part on action reaction pair. Can? All right, let me move on already. Okay, next part for this balloon, there's being a center of gravity and labeling of the weight should be at the middle of the object. All right. So some of you are wondering, can I label weight at the bottom? Can I label it at the side? My answer is that if the question specifies for you to mark out the center of gravity and then label the force, right? You are expected to know that the weight acts upon that point where you identify as your COG. Now, for the upward force, it doesn't really matter whether it's on the surface or what, but usually we like to draw it on the surface because that's where the force is acting on. Okay, so for labeling questions itself, please be very careful. Label it in pencil, otherwise you cannot erase it. Right? My own personal story, yeah, I tell all my students before. There was one question that says label all forces acting on the diagram, and I completely missed that out. And therefore, I lost like 3 marks in my physics exam when I took it. So please don't be like me, don't be an idiot. All right, go and make sure you attempt every single question, and especially when it comes to labeling, make sure you actually go over to the diagram to label it. Okay, for most questions when it comes to vector diagram, right? If I can give you all a pro tip, is that if your math is good, you can actually use your sine rule to calculate what is the expected answer. So if you take a look at this question, right, using 4.2, determine the value of f. What you are supposed to do is to take out your ruler, measure the length of this line over here, and equate it to 0.4 Newton to know what the scale is. So the scale is like 1 cm represents 0.04. So you then take another ruler, not same ruler, to go and measure what is the length of my F. All right. And then you're like, okay, F is 5.8. So I multiply, I get my answer. This is how you use figure 4.2 to determine the value. But how do you check if this 0.23 is correct? You can check literally using your calculator, using sine rule to calculate this. Why? Because this is 30/30. Means what is this angle over here? This angle is 120. So you can go and sine rule 100, sine 120, 0.4. What is 30? What's the value of f? So you can confirm plus chop, right? Your answer is correct. Okay, yes, this one you measure one of the f will do because the values will be equal because it's ultimately an isosceles triangle. So use your math to help you here to double check your answer. But if you use that to solve, you don't get the mark because they say using figure 4.2. So I'm telling you how do you confirm your answer is correct. Can? Now I move on. So you realize I'm not going through the full question. I don't find much value in that because you guys probably have attempted your yearly paper. My job here, right, is can I tell you some stuff that you don't know? That is the key thing over here. Now, another thing that I want you to focus on when it comes to dynamics question is really the relentlessness to remind yourself that it's not F equals to MA, but RF equals to MA, where RF stands for resultant force. So a lot of people tend to memorize the definition. They go like, oh, F equals to MA, F equals to MA. But do we just use F equals to MA? We don't. Because we need to acknowledge that this F here is not force, but resultant force. And resultant force means you have to include all of the forces acting on the object. The result of it, I then equals to MA to calculate my acceleration. So please don't be tricked into, oh, I got F 95. No, it should be your 95 minus your 61. Your result of it, the resultant force. I then use it to calculate the acceleration. So this is another very common pitfall for a lot of students. So tomorrow, please take care of it. Now, answers in 2 or 3 SF, this one your school has gone through. If you know what I'm talking about, you're supposed to leave to the least SF, at least 2. Okay, if your school didn't teach you, just leave it in 3 SF. Unfortunately, at this point, that would be my best recommendation. Okay, factors that affects air resistance is very clear. It's just how fast the object is moving as well as the surface area. If you ultimately end up with a scenario where resultant force is 0, you can expect that the object, it will not stop. It's just that there's no acceleration and you're experiencing a constant velocity. You get what I mean? So 0 resultant force doesn't mean the object stops moving. It just means that there's no further acceleration, means I don't move faster, but I can still be moving. All right. So a lot of people tend to think, oh, no resultant force means object stop. Not true. All right. do expect that there will be a couple of definition questions. For those of you who have the curated notes, I recommend you go over to the back, whereby we already done out the compilation. So go and study all of the key definitions as listed, because there will be at minimum about a few marks of definition. My style is that when they say, hey, students, you can check your paper. I flip, right? Because they say, oh, must check whether the pages are printed. Screw that, pages obviously is printed. So I'm just flipping through, I'm just finding all the definition questions first. Then in my mind, I just start recalling. Then the moment they say you may start, right? I just straight away go to the definition question and write down all the definition. Then I go back to my question one and start doing so that I don't lose that memory. All right. So definition question, you have to be very, very precise, meaning you really need to give every single keyword here. So it's like about a pivot is equal to the total anti-clockwise moment. This kind of things is you tonight you go and study, right? All right. There's just no way around it. This marks, if you know, you get it. If you don't, unfortunately, you're dropping very wasted marks. All right. So please tonight, go and spend some time to read through again. Make sure you understand and you can remember everything for tomorrow. Now, typically for a moments question, it will always be the clockwise equals to sum of anti-clockwise moment. My personal take is I always make it a point, all right, to really identify very clearly all the different forces acting on the system, all right, and therefore be able to conclude whether they are clockwise or anti-clockwise, right? And make sure you get your perpendicular distance right. You see, the most stupid thing is that you tell me, oh, Joe, this one, right, the man, I times 2.5. No lah, it's the total perpendicular distance, right? So you're supposed to add the 0.9 to the 2.5. This is a 3.4 meter clockwise moment. Okay, so just be careful. It's not that you cannot do it, because the moment you establish where your pivot is, the perpendicular distance is the easy part. And whatever calculation come your way, you just need to be careful when it comes to it. Okay, so all I'm telling you here is don't get your perpendicular distance wrong. Now, sometimes they would mess you over with the units. If it's in meters, you can convert it to cm to meters, but it's just dependent on like how you do it. So this one is not that scary, so I won't spend too long. This is a pro tip. So in case you haven't realized, right, the second part of the question is always upward equals to downward force. So it's been said many, many times at O level already. Part one is usually 3 marks or 2 marks sometimes. They ask you to calculate total clockwise equals to total anti-clockwise. Solve, F times D, you'll get your answer. Then the second half of the question is total upward equals to total downward force. And if you do that, you get a second mark. And this mark is usually 1 mark. So it's actually very easy to score the second 1 mark. You don't have to do moments again. All right. So tomorrow, if it comes out, go and look out for this one. This one is always going to be upwards equals to downward force. Okay. Next up, when it comes to pressure questions, I think that generally most of us underestimate, right, how difficult pressure questions can be. But at the same time, pressure question is not that difficult. Why? There's only a few formulas you can use. Now, the first formula that we all know by now, right, is pressure equals to force over area. So for questions that ask us, hey, help me calculate the force, it's really just taking force times area. Okay. But the caveat here is this. Make sure you get your units right. I know the question here was kind. They give you in meter square. But do you think they can give you in cm square? They can. And you're expected to know that the correct unit for area is meter square, because the SI unit for length is meters, not cm. So this is one area that you want to look out for, because sometimes the units, they will not be so kind one. So you need to know how to convert between your cm square to your meter square, or if it's a density question, a cm cube to a meter cube. So if you don't feel confident, tonight go and revise again. All right. So this one is like, I'm not saying that, oh, you can't do the formula. Can one. Okay, it's just the units that you need to be careful about. Can? Moving on. So one thing that I need you all to know, right, is that when you're dealing with pressure questions, right, because there's a force, there's a direction. So if you have a liquid, the pressure throughout is constant. So over here, the oil is pushing outwards against atmospheric pressure as well as the F value here. And we are tasked to solve for the value of F. Now, for those of you who don't feel very good about atmospheric pressure, let me explain just a little more. Now, atmospheric pressure is the pressure exerted by the air molecules around us. So any surface that's exposed to air will experience atmospheric pressure. In other words, the oil inside is not exposed to air, right? Because it's inside a container. So there's no atmospheric pressure. But can you see this surface over here, which is the piston? the external surface, is exposed to air. So if air molecules will bombard on this surface, it exerts a force, it exerts atmospheric pressure. So at any point in time, if you're confused, you're like, oh, where does atmospheric pressure act on? Just remember this. It acts on an exposed surface that is exposed to air. Okay, that sounds a bit weird, but you get it, right? If a surface is exposed to air, it experiences atmospheric pressure. Okay, I will move on. Okay, does an object in water experiences atmospheric pressure? Now, let's say if this is the surface of the water, my object is here. The object will experience not only the liquid pressure due to rho GH, it will also experience atmospheric pressure as this surface of the water is exposed to air. But if you cap it and it's not exposed to air, then there's no atmospheric pressure. So the only question you have to ask yourself is whether the surface is exposed to air. You get it? Okay, I'll come to rho GH in a bit because that's very important. Most of you would know the hydraulic press equation, which is F1 over A1, F2 over A2. So over here, when it comes to pressure transmission, P is always constant. But if you have a larger area, you can have a larger force. A smaller area means a smaller force. So I think this is a very good way for us to digest this concept. F big over A big, F small over A small. Okay? So if you're in a vacuum, there's no atmospheric pressure, right? Because there is no air molecule. That's it. Okay, so just understand that whenever I deal with atmospheric pressure, is whether I'm exposed to air or not. Okay, next. You all get what I mean here? I highlight, you see if you can spot what I'm trying to tell you. So where would you screw up for this question? It's not that you do not know the formula for density. Everybody knows density, right? Density equals to a broken heart. Because if a guy is very dense, he doesn't get it, his heart will be broken. Okay, M over V, right? So density equals to mass over volume. But where will you screw up? Your units. What's the unit here? 20 cm. And what did we say about volume? SI unit for length is meters, meaning the correct formula for volume should be in meters. Meter time meter time meter. So if you screw up here, it's as simple as you didn't take care of your units. And this is a consistent thing throughout physics. So the biggest careless mistake you can have tomorrow is just not taking care of your units properly. So I want you all to just pay extra attention when it comes to anything involving units. You need to double check if you have converted your units. The question is not expected to help you here. You are supposed to know to convert the units. Okay, even for the area itself, it's supposed to be in meter square. If it's not in meter square, your final answer in Pascal will be wrong. And this is another thing that I like to highlight to you. See, the reason why I highlighted this is very simple. This 0.12 is your height. And where is this height? Is the height of the liquid column. But once again, what about the units? You notice they like to give you in cm. It is your job to convert these units to meters because the SI unit for length is supposed to be in meters. So let me say very, very clearly here. If liquid pressure is tested, they are likely to trick you by leaving the height in cm. And you must remind yourself that, hey, I will not be the idiot. I will convert my units to meters. Everybody know liquid pressure is rho GH, but people still get the H unit wrong. So whenever you're talking about your mercury barometer and stuff, 76 cm Hg, screw that. It is 0.76 meters. Clear? Okay, so please, you see, the stupid thing here is this. I keep repeating the same point, but you guys will be making the same mistake. So if you're tuning in today, you must really, put it in your brain that I'm not going to be tricked by the units itself. Okay, then I will leave it already. Now, is it always in meters? The word always is dangerous, not always, but usually it should be in meters. Why? Because you need to always put it in SI unit form. There are occasions whereby you can take force times distance equals to force times distance, clockwise, anti-clockwise, and you're allowed to leave both units in cm. But imagine if you convert to meters, it's still okay, what? You still get the same answer. So if you ask me, if you want to be a blanket statement, you want to be extremely safe, you just do it in meters. You almost certainly never go wrong. Okay, so I won't go into details on some of your questions because I need to make sure I cover more depth So please bear with me if I don't answer your questions. Not because it's a bad question, it's just because I want to cover more. All right. Now, the next question we're looking at is the 2021 question. Now, even here, you can see that you need to know how to convert from km per hour to meters per second, because meters per second is your SI unit. You then take half mv squared to calculate your kinetic energy. This is not difficult. Now, be ready, right, that there will be a data response question, right? You guys know it's coming. And this kind of questions typically come with a lot of numbers. Now, one pro tip that I'm going to leave with you guys here, right, is don't bother reading this too much in detail yet. What you want to do is to read through the entire question, including the questions first. So you roughly know where this question is going with. Like, oh, it's gonna go by asking me a maximum distance for a fully charged car. Okay, they want me to calculate the mass of the battery. They then want me to compare when I use battery versus petrol and how much time it takes to charge the car. Now that you have a better sensing of what the question is asking of you, you then go back to the information to dissect. Okay, battery stores this amount of energy. How much does it use? And slowly you'll be able to form out certain formulas that will be appropriate for the question. Okay, so my main point here is when you're dealing with data response question, at least read through the entire question once first, understand what the question is asking from you before you go back and you take a look. All right. And when it comes to calculation and stuff, just be very careful with, once again, your units and making sure you're reading the question carefully. All right. A general tip that I always give is for data response question, leave it till the end, meaning you do the rest of your paper and you come back to data response last. Okay, how long to spend on data response is really anybody's guess. I'll say nothing longer than 20 minutes. If you're spending more than 20 minutes, you're killing yourself. Okay, but if you finish the entire paper and you have time, feel free to attempt. I highly encourage attempting. That means you must try, but I don't think you need to say, I need to score full marks here. Scoring full marks for data response is unrealistic. Okay, if there's one thing I can leave with you guys, right, instead of the answer going through all of that, can I just get you guys to look at this phrase and deeply understand what it means? If a question asks you to use the data from table 9.1, the skill set that Cambridge is testing you on is, are you able to synthesize information from the question that is provided, all the information relevantly to explain? Meaning, if you didn't quote information like 1 kg, 80% output is this versus 1 kg of petrol gives me an output of this, you never use data from the table, you will not get the mark. All right. So how do you actually check whether the claim is correct or wrong? You need to pull out data from the table. And most importantly, you need to pull out the correct data. Right? If you pull out the wrong data, then no, you are also not explaining it correctly. Okay. So I think the ask here is for you to understand the question requirement. Okay. Usually is one data response. But there's no way of knowing whether there will be two data response or not. If it comes out, just do lah. But usually it's one. Okay, usually. Okay, moving on. Next one is more about the energy portion. So stating conservation of energy is another very popular definition. So principle of moments, principle of conservation of energy. These two are quite commonly tested in terms of definition. Okay, whenever it comes to calculation, just remember this. At the end of the day, energy cannot be created nor destroyed. So if there's a change in your GPE or your gravitational potential store, it's likely transferred to your kinetic store. So whatever calculations that you're doing, right, your final sum will be the same. Okay. And I just want you all to be very conscious that when you're doing any calculations when it comes to energy, once again, take care of your units. There's one very common mistake. Maybe I just verbally share. When we say loss, or basically your decrease or transfer from the kinetic store, right? Make sure that you do not take, for example, if your initial velocity is, say, 1 meter per second, then your final velocity is hypothetically, let's say, 4 meters per second. You do not calculate the decrease in the KE by taking half mv square, and your V here, right, is taking 4 minus 1 square. This is wrong. Okay, so you do not subtract the velocity directly, meaning 4 minus 1. This is different. Different from what? This is different from the correct answer where it's supposed to be half mv square minus half mv square. which is supposed to be half times mass times 4 square minus half times mass times 1 square. 4 square minus 1 square is different to bracket 4 minus 1 close bracket square. So when you're calculating the change or whatever difference in your kinetic energy, you need to take half mv square minus half mv square. Okay, you are not allowed to subtract the velocity directly. However, if it's height, you can do so. Okay, can the values here itself, right? You realize it's different because a minus b square or a bracket a minus b square is different from a square minus b square. Can I? So just be very careful when it comes to this one careless mistake. Let's move on. Okay, so there are a lot of questions where they ask you about how the transfer of store works. So if you're still not very familiar with the phrasing, what I recommend you can do is to take out your textbook or your TYS answers tonight to make sure that when you're going through, you are clear in terms of how to describe the transfer to the internal store of the surrounding, provided there's air resistance or friction. Okay, so you're not allowed to say heat loss to surrounding anymore. Okay, because that is wrong already. That's not the correct phrasing. That's the old syllabus phrasing. The new syllabus requires you to talk about how there's energy transferred to the internal store of the surrounding due to air resistance, or you're saying work done against friction is transferred to the internal store. All right. How is being transferred is then thermally, mechanically, or via your wave or electricity. All right. So please go and revise this concept if you still don't feel confident. Okay. Now, the thing with Brownian motion is that I think people know Brownian motion, but the year when it came out where they asked to draw a labeled diagram, nobody can draw. Okay, so just in case I wanted to capture this, so I made sure to include it in the TYS highlight. So making a point, if they say labeled diagram, you must label, and then you're supposed to give a brief explanation of how this whole thing works. Brownian motion is not commonly tested, okay, but should it be tested, the only thing most of us will struggle with is the diagram. So please spend some time to go and look through the diagram, especially if you're still not clear. Can? Now, at the end of the day, remember this. What you see is the constant random motion of the smoke particle, but what is causing it is the uneven bombardment by the small invisible air molecules. That is more or less the only thing you need to pay attention to. All right, now there are other types of questions relating how temperature and pressure is related. So at the end of the day, you just need to know that when temperature increase, pressure will increase. How you explain it is really just about the air molecules bombarding more frequently, and when they bombard, they exert a larger force. Right? There are a lot of questions that are removed from your new syllabus regarding ideal gas law. So you do not technically need to know the relationship, say, between pressure and volume or volume or temperature. But I know some schools still do teach, but I think it's quite clear based on the learning outcome published by SEAB that that's no longer in the syllabus. You can still study it to be safe, but at the end of the day, it's really just a case about making sure you know how to explain pressure in terms of force. So ultimately, pressure is force over area. So in your explanation, if you didn't mention force or per unit area, you're screwed, lah, right? If not, how are you going to explain pressure? Can? Okay, now you need to understand sometimes your teachers might go out of syllabus, teach you extra stuff. I think that's fine for you to understand. But at the same time, it is important for you to know exactly, let's say, for a certain chapter, what are the exact things you need to know from the learning outcome. So if you don't have, you're wondering like, what is this? And I never see this before in my life. You've never seen this before in your life, you're screwed because this is your syllabus. It tells you exactly what you need to know and what they can test you on. So if you have your textbook, I think they might put it at the front. For those with the curated notes, it's at the start of every chapter. So whether it's in the syllabus or not is actually very clear. So over here, when you're looking at the question type here, you only need to know the relationship between pressure and temperature. You know, I might as well just show you all. Sometimes I say so much, also no point, and show you all directly. So you're only supposed to know how to describe pressure in terms of the motion of its particle. You're not required to talk about, all of how the pressure, volume, and temperature is related. So a lot of you, when you are like looking at your school paper and stuff, you might realize that some of the older prelim questions you cannot solve. Not because you don't know how to do, because it's out of syllabus already. Okay, next up, very common for you to be tested on transfer of heat. All right, so you need to know very clearly your three methods: conduction, convection, and radiation. Okay, so typically one of the more common trends nowadays is testing you on heat transfer in the filament lamp itself. The reason why it's interesting is because it connects a chapter of electricity with a chapter in thermal. Now, one thing I need you all to know, for part A at least, is why does the filament lamp glow brightly? I don't think this is well explained in schools. Now, provided, right, if your filament lamp is efficient, meaning it actually doesn't have a lot of resistance, by right, electricity energy is supposed to be transferred electrically, right, without much transfer to the surrounding, the store of the surrounding. But because, right, the filament lamp is designed to have very, very high resistance, this is such that when you transfer energy electrically, there's a lot of power loss. And the power loss is in the form of light and heat. All right. So the energy transfer method is via light and heat. So at the end of the day, what is happening in the filament is basically, in short, electricity turns into light and heat. Okay, but that's not the best way to phrase it. Okay, but my main point is I need you to visualize what's going on. That's why your light bulb lights up. All right, it's because of the resistance of the filament itself. Therefore, the filament is usually made of a metal with extremely high resistivity, such as tungsten. Okay. Heat transfer method, one point to note is that if you're tested on convection, please mention density. Basically, if your answer doesn't have the word density, you have no way to justify why the gas rise. Don't tell me I heat up the gas expands and rises. No, it expands and the air becomes less dense. And that's why a less dense gas rises. Same for a liquid. So my main point here is if you're going to go down the convection current explanation, please mention density. Okay, moving on. Okay. This question over here, next one is the 2023 paper, right? We see that we're using a heater to melt ice. This question overall, I would not say is very difficult, but as you can see, they are moving you towards, right? Can you tell me conduction, convection, radiation, and explain in context to the question? So nowadays, they don't really ask for a give me definition, maybe 1 to 2 marks or a couple of questions, but majority of it would be like, tell me how this concept applies to this situation. All right. And you must know what are the keywords to bring up when explaining conduction, convection, and radiation. All right. In fact, most of the time, all three can be occurring. It's just which one is more prominent. So, which one is responsible for more of the heat transfer? So this one is something that I recommend you guys study again tonight because the phrasing needs to be very precise. The funny part is that when it comes to such, everybody knows it's conduction, convection, and radiation, but not everybody can calculate it precisely and correctly or explain it precisely enough with the correct keywords. Okay, and when it comes to specific latent heat of fusion or specific latent heat of vaporization question or heat capacity, specific heat capacity, take care of your units, especially the mass, because the mass could be in grams or kg. So what are the few chapters where units are important? Kinematics, not really, sorry. Dynamics, where the mass kg gram before you calculate weight, moments, density, and heat. Heat, the unit, you need to be careful. Pressure as well, as I've highlighted earlier. So it's really just about being careful with your units. So the calculation here is usually quite standard. You just need to apply your formula. All right. And graph sketching is usually where it gets a little scary, right? We're just like, oh shit, how to sketch. So a lot of us, when we are sketching this, right, you actually see that you know how to sketch, but you end off at the same level. That means you end off at like 65 instead of ending it off at a higher value. Now, for such situations, you need to analyze and think, would the maximum temperature reach be higher or lower? So when it comes across as sketching, most of the time it doesn't have to be very precise because they say sketch. But let's take a look at a couple of things here that makes this question more interesting. So first thing, right, is do you see that the energy supplied, the per unit time here is per minutes. So if they mention it is per minutes, you do not need to convert it to per second and do all of your calculation from there. You can leave all of your per unit of time in minutes and all of your calculation to be, say, joules per minute. So earlier you're asking me, must I convert my unit? It's not a must. It depends on the question. The difference between pure and combined, if you're never really wondered what's the difference, is that in combined, they usually give the units. So they guide you in terms of like, what's your final answer? You just need to calculate to that point. But in pure, usually the units is open-ended, meaning they expect you to know how to deal with your units. So that's why there's different levels of difficulties when it comes to pure versus combined. All right. But at the end of the day, I would say that you need to be ready also for a specific heat capacity or latent heat of vaporization and latent heat of fusion question. Right. So these are the kind of question that I tend to skip. Oh. That means I didn't read it because I go through too fast. I straight away, explain and I go to the next line. So make sure that all marks are attempted. When they say sketch a new line to show the variation, right? Why does the line differ? Firstly, right, if you add in a lid, it prevents heat transfer to the surrounding. So the rate of increase in temperature will be faster and the maximum temperature will increase. So when it comes to what's the maximum temperature that I can reach, maximum temperature is reached when I hit thermal equilibrium, where the heat transfer to the surrounding is as fast as the heat gain. But by putting a lid, the transfer to the surrounding is reduced, allowing the heat gain to hit a higher value. That's why the temperature of the water here can hit a higher value. So most people doing this for the first time would draw a graph resembling something more like what I draw. Most of you end off at the same maximum temperature, but go and consider whether the temperature it should reach should be higher than before. All right, I'll say that is one of the key considerations. Now, I know I really didn't have the chance to go deep into the question, but like I said, every single question you can see which year and therefore go back and revisit it. I picked out and selected this question because across my 10 years of teaching, these are the questions students cannot answer. Okay, so if you find that, wow, Joe, today whatever you're saying, I really don't feel confident, you have tomorrow morning to revisit all of these concepts again. All right, I'm gonna go for a quick break here. We're gonna come back at 8:30. But 8:30 is when we begin the scarier part, the second half, right? Of the topics that you are less confident in, starting from waves all the way to electricity. Okay, so go for a solid break. Let's regroup at 8:30. And when we do so, we'll look through the second half of the questions. All right, I still need your TLS, so keep it beside you. So I want to resume the session. We're going to cover the second half. As I said once again, I cannot or I am unable to go through every single question in detail. All I can tell you is what to look out for each question. All right, so with that, let's jump straight in. I hope you guys are still alive and following me well. Okay, let's power through this. Now, this question, the 2018 question, I strongly believe that many of you till now, the day before your actual O level, you actually don't know how this question works still. Right? This question, the first part, the definitions and stuff, calculating frequency, blah, is easy stuff. It is part C that I'm worried about. Right? Point B is 38 cm to the right of point A. There are several possible values, and one of the possible value is 200. So how do you know and show you're working on how you derive that? My opinion is that most of you, if I ask you to do this question now, you still cannot do it. Okay, if you know it's good, all right. But let's run through what is happening here for this wave. Now, a lot of us when we first see these two waves, A and B, would think that okay, how do I break it down? What do I need to think about? But you first need to acknowledge, right, that these 2 points are on the same rope. They are 2 points on the rope A, B. What this means, right, is that if I have a rope itself, this A and B are located on the same wave. But at timing zero, A is currently at equilibrium. At timing zero, B is currently at negative displacement. What I've done is I've skipped a bit of the analysis. I jump straight to the correct answer. Look at this point, the dotted one in blue. This is where A is at. How do I know that? By studying its next subsequent displacement over time, at 0 seconds, A is at equilibrium. At zero point 0.2 seconds, A would be at maximum positive displacement. Press. I go back to equilibrium. I'll go back to the throw. I'll go back to equilibrium. If you observe this particle over here, this particle's next immediate movement, which is its oscillation, it will go up, down, down, up. How do I know that? Because if I hypothetically drew in the next adjacent wave, we can see that this blue dot's immediate movement is to move up to form the next crest. After I hit the highest point, I have to come down back to equilibrium, hit the lowest point before going back as I complete one full cycle. So in other words, right, if you're trying to identify where A is on a wave, A's movement, as we have just talked about, is supposed to be up, down, down, up, which matches this position. This is how I say that A is exactly here on a wave. For B, right, B is a bit easier to digest. Why do I say so? B is currently at the lowest. What is its full set of movement? It will go up, up, down, down. This is a displacement time graph. So how far do I displace over time? So for B, it's quite clear. Something that is at the lowest point will go up, up, then down, down. So B is located currently at the crest at the throw at 0 seconds. So if A is here and B is here, and this entire thing is the rope that they are on, they are currently 1/4 of a wave apart. And if their distance apart is 38 cm, 38 cm is 1/4 of a wave. Therefore, one wavelength is about 4 times 38. The wavelength is about 152. So V equals to F lambda. So V times F lambda is approximately rounded up to 200. Okay. I know I went through a bit faster. Usually I spend a bit longer on this question, but you guys hopefully smart enough to follow what I'm saying. But my main point is that with the displacement time graph for A and B, you are supposed to locate where these particles are on the wave. And if you located them correctly, and the question tells you that they are 38 cm apart, and your analysis is that they are 1/4 apart, 38 cm is 1/4. Then from there is the easy part with V equals to F lambda. Okay. The second half of the question usually accompanies why are there other possible values? Because it's true that they could be 1/4 of a wave apart, or they could be 1 and 1/4, 2 and 2/4, and so on. Because the any two particles that are one wavelength apart are in phase. So for a particle to go up, up, down, down, yes, you could be 1/4 or you could be 1 and 1/4, and you still have the same motion. So that's why part two is always why are there other possible values? The reason why I'm worried for this question itself is because the understanding is not strong. 2018 is not that far away for them to say I'm going to retest this. Fingers crossed it doesn't come out, lah, right? But if it really comes out, I need you all to understand how this works. Can I? I hope it won't come out, lah, but if it comes out, make sure you know how to do it. Okay, so this is how it works. This is from the 2018, if you want to revisit this question again. Okay, next up, some typical definition questions. So this one I'm not going to go through. I'll say this one is a bit more interesting, all right, for you to learn how to draw in the wave that's 1/4 wavelength further away. All right, so over here, right, at the bottom, they say that point Y is 1/4 of a wavelength further from the loudspeaker. So whenever you're drawing, it's as though you do copy paste, right? Control C, Control V, but you shift the graph by 1/4. So what I highly recommend you do is to plot out the points that are important guidelines before you sketch. Otherwise, the shape of your graph, right, will look like shit. All right, that's just the truth. Because I do it very uglily as well. My own students would know, right? My handwriting is atrocious. But by plotting out the important coordinates before drawing it in, it will really help. One pro tip, this one, please listen to me. What's the unit for time here? Milliseconds. So if you want to calculate frequency, do you just divide by the value directly? No, right? It's times 10 to a power of -3. So once again, that is another area where it can get a bit tricky. Can? Moving on. Right, this question itself was quite a disaster when it came out. This was in the 2022 one regarding the earthquake. Now, it's not so much that the question's like, okay, I need to score everything 100%. Why? Because it's ultimately considered a data response. But I just need you all to be very clear, right? Whenever we come with different types of waves, right? The difference is usually your transverse versus your longitudinal, right? And the kind of questions that they will ask, right, is really about time taken for the wave to travel from one point to another. But more importantly, right, the reason why we selected this question for discussion is really the word here, not proportional. I know a little bit of sparing error, okay, guys, but not proportional. Why is this very important? I want you all to pay attention to this phrase as well. What did we talk about earlier? If the command of the question, what the question requires of you is to use data from the table. And in your question, I do not see any values. It's as good as saying that you don't get the mark lah. Like you don't write anything also better, save time. Right? Because at the end of the day, if you're supposed to use the data, you're supposed to show via calculation that, hey, my distance times 2, but my time taken didn't times 2. That's why it is not proportional. Do they have a positive relationship? Yes, because if one increase, the other one increase. But are they proportional? Are they per ratio via calculation the same? That means when I increase times two, the other one times two as well. Is it directly proportional? And the answer is no. Okay, so in physics, you need to be very clear the difference between having a positive relationship, a negative relationship, versus whether it's proportional or not. Whenever the word proportional appears, usually it means you have to come in via some form of a calculation. Okay, so it means you need to use numbers to prove whether it's proportional or not. Okay. And the reason why this question was very difficult was really because of the last part. But if you notice, it's just 1 mark. Lah. So if you don't get it, it's fine. But it's really about understanding that sound travels in a radial manner. So if you actually draw the circumference, the two areas where they overlap, right, this could be where the earthquake originated. So by the time it travels to X1 and X2, that's the distance traveled and when the sound is detected. So a very challenging question in terms of the concept. But like I said, don't worry if you can't score full marks here. Why? Because you don't score full marks for data response, you can still do very, very well. Okay, questions on ultrasound is quite important. Now, the word ultrasound means is a sound wave. Okay, so please don't think ultrasound suddenly become EM wave, right? It's just that ultrasound has such high frequency that our human ears cannot hear it, right? And therefore we use it for other things like, for example, for the ultrasound scanning for the baby in the womb and stuff like that. All right. The description of ultrasound is still the description of how a sound wave propagates. All right. So it's about reflecting back when it hits the tissue of the mother's body, and we're calculating the time taken, all right, to come up with a processing of the image. In fact, the formula is still V equals to F lambda. So nothing too special here. All right. Infrasound, not really. I don't, that's definitely not in the syllabus. All right. But ultrasound, 100% is. Okay, now for lens question, this one, I think Xavier, if you're here, you spotted it really well. The answer key is actually wrong, so I actually had to spend some time to go and recorrect it. But one thing for you all to note here is that when it comes to a light ray, one of the most commonly tested light ray diagram is your magnifying glass. So if today you still do not know how to draw your magnifying glass, go and revise it again. Okay, if I'm not wrong, it came out about 3 times in the past 10 to 12 years. I can't confirm, but it is the most commonly tested one. All right, so please understand how to backtrack from your line to where the image is. Image should be a dotted line. The construction lines are dotted lines. Only the solid lines represent the actual light ray. And for those of you that still do not know how to define virtual, oh, virtual image is not real. Nonsense. Virtual image is an image that cannot be captured or formed on the screen. All right, this is the only official definition, nothing else. Anything else you try is all nonsense. Okay, so when you put a screen behind a mirror, I don't get an image, right? So the image that you see in the mirror is just a virtual image, doesn't actually exist. Can definition of focal length is quite common, so please go and revise it. But like I said, definition questions will have, but just study it before. If it comes out, answer it first. Okay, a few things to take note when you're drawing any light ray diagram. Firstly, check, right, if you added in your arrows, right? Check whether you correctly use dotted or solid lines where appropriate. Okay, and make sure that for any light ray diagrams you draw, always do it in pencil, right? Because you might need to erase to redraw it again. Can I? So a visualizer is real because it can obviously be captured on the screen, right? That's how you see it. Okay. And whenever it comes to any ray diagrams, I would say in general, my best tip is to make sure to add in the normal when you draw. Now, I know a lot of you feel very uncomfortable with lens and stuff, but at the end of the day, lens is just a piece of glass. And it's just how light ray behaves when light enters an optically denser medium. So in case you don't believe me, right, can you see over here? This is normal and the light ray. This is your angle of incidence from air going into the glass. Can you see technically what has happened here is that there's a bending towards the normal as I go from air to glass. So at the end of the day, right, whenever you're doing any questions related to glass, you can see this as well. As I exit from glass to air, it bends away from the normal. So it is the curvature of the lens that causes your light rays to bend in a certain way that allows you to capture a sharp image. Okay? This one's another very popular one. For those of you who have been doing your TYS, this appeared in the 2022 paper about why there's like this circular ray. This is a very common one. First tip, please draw in your normal. This is so important because you're supposed to use the angle between the light ray and the normal. This is 30 degrees, and this over here is 60. All right, so this one over here will just undergo normal refraction. Okay, while this one here will undergo total internal reflection. So if you're wondering like what 60/30 it doesn't make sense, eh? What? It's because you are supposed to use the other angle instead. Okay, so that's why A will emerge into the air if angle of incidence is less than your critical angle, all right? But for light ray B, it will undergo total internal reflection. Okay? And optic fiber is the only official application of total internal reflection that you need to know. They can test you on more, but they're required to provide information. But optic fiber is like officially in your syllabus. So you must know how it works, how the total internal reflection causes loss of signal to be less, okay, and the transfer of data is also faster. So all of these things you can find in your notes one. Okay, so go back to your notes to study how light works. Where is it? Let me find it. Okay, so over here. So under optic fiber. Okay, so these are things that you need to know. Let's go back to the worksheet. Okay, I know some of you will be wondering, hey, Cher, what is this Snell's law? My teacher got teach. My teacher never teach. The truth is that, right, for Snell's law, it is officially not in O-level syllabus, but it's very useful. That's why some of the schools teach it. Personally, I do as well, but I do not put too big of an emphasis on it because by right, even without Snell's law, you can still answer. All right. So if you need a conclusive answer, do you need to know Snell's law or not? Answer is by O-level standard, no. But it is helpful to learn. All right. This one is about the sound wave traveling one. I'll skip through this. I don't think it's super difficult. I would say the main thing here is really your ability to analyze your compression and rarefaction for longitudinal wave. I typically find that to be a pretty big area of weakness. Generally, I would say the easiest way to spot them, right, is if you see everything squeezing towards a certain dot, that forms the center of your compression. And from the center of compression to the next, that is one wavelength. This is one rarefaction to the next. How do I know? Is because everything is moving away from this, making this and this the rarefaction. This could form one wavelength as well. So there's more than one correct answer for part Y, lah, right? Because they say mark a distance such as the wavelength. So it can be from C to C or even from R to R. The fun fact, right, is this. If your time is half a period away, all of your C's becomes R, all of your R's become C. What am I writing? Yeah. So everything will flip. So if you go back over here, you can see that this one used to be a R, now is the compression. Then if you were formerly the compression, now you become a rarefaction. Okay, this one's the compression, now this is the rarefaction. All right, so half a cycle apart means that all of it will swap. It's not because they move, but it's more of like the particles beside them either move away or towards them. All right, so that's the main thing you need to remember for half a cycle away. Okay. Another seemingly deceivingly hard or easy question. So the thing here is this. Whenever you get static questions, right, you need to be very careful and read the question. What I mean is this. If they ask you to state the steps, or typically what they do is describe. You're supposed to describe step by step how to charge the object. But if the question goes over and uses the word explain, explain, you then need to talk about, oh, it induces the electron to move here, move there. The difference is that step part one is give me instructions on how to do the charging. I move the rod in, I move the ball out, I it, whatever, right? What are the physical steps that I need to take? But if the word here is explain, explains means you are required to tell me why it works like that, right? Is it about the induction and the movement of electrons, right? How does it work internally? How does the electrons flow? How does the charges redistribute themselves? That is the key thing when it comes to explain why or explain what has happened. So please don't write the wrong answer for each part. Read both parts first and then determine what they're asking. Usually one part is describe how, second part is explain why. And if you can do that, right, then I would say easy game, you will get the marks. Okay, I'll skip some of this because technically photocopier is not officially in your syllabus anymore. Okay, now this one y'all realize what's the wording is explain why. Explain why means I want the reasoning. Tell me based on the movement of charges, how does it work? Now this part, right, I think is worth me talking about it a little bit more. Right? I think most of us understand, right? Unlike charges, induction, blah, blah, blah. But I want you to pay attention to the wording here, all right? Because not all the schools teach this. So read this part. What the hell is going on? If your first time seeing this, right? This is what unfortunately, I'll be very blunt, the better schools are teaching that the force of attraction is stronger than the force of repulsion. Now, what exactly is going on? When you put the positively charged rod, it induces the negative charge to be on the left side. As these two are closer in distance, they exert a attraction towards one another as unlike charges attract. So we call this a force of attraction. Now, at the same time, we acknowledge that this plus and plus, they also experience some version of repulsion. But we can agree, right? The distance between the plus and plus is further apart. So we say that the forces of attraction between the negative electrons in the sphere and the rod, right, is stronger than the force of repulsion between the rod and the positive region in the sphere. You get what I mean? So we're not saying that, oh, unlike charges attract so simplistically. We are saying that yes, there's both attraction and repulsion, but the attraction here is stronger than the repulsion. Therefore, the metal sphere is attracted to the rod. Okay, can can I just maybe get a show of voting? How many of your schools actually teach you this? Force of attraction, force of repulsion. Have, right? Those can you raise your hand? Okay, so for the rest in the chat, it is not me. I'm not saying this. I know this because I teach so many students and they're telling me, Cher, this is what my school is teaching me. So for those of you who say yes, or those of you who's never learned this before, I'm telling you that some schools are teaching this. All right. And therefore, this is the better phrasing, honestly. Okay. Even from a physics perspective. Right. So thanks for participating. But this is just to let those that didn't, or your school teacher didn't teach, right? Just for you to know that this is how it's supposed to be answered. Can? All right. Now, the rest I won't go through too much. All right. But can you see one more time, right? Let me just nag you all for the last time. Describe how is the steps. You get it? Step by step, I earth the uncharged rod. I do this, I do that. Okay. So when it comes to the word describe, is describe how. Clear? All right. So describe the movement of charge. So you tell me what has happened. You don't have to tell me the explanation behind it. But usually when it comes to explanation, you might need to go in depth a little, right? To talk about force of attraction, blah, blah, blah. Let's move gear. Let's move into electricity. Now, I know static electricity is painful, but it's one of those chapters that you really want to secure the marks. All right. Now, for electricity question, right? Conceptually, right, is really just a case of like, how well do you know your concepts? One thing that I'm very against is just purely memorizing formulas because yes, that can get you the base, but a lot of questions you cannot solve. So it's very dangerous. But let me talk about a key focus. Because if I just keep yapping about like what y'all do not know, it doesn't help. So let me tell you exactly what could come out and what to look out for. And this is the one. Okay, now let's recap what's the concept. Resistance equals to resistivity times length over cross-sectional area. Correct? This is the formula. But if you take pure physics, unfortunately, you cannot know just this formula, right? Instead of this formula, right, change this. Resistance equals to resistivity times length. Area is pi r square. This is so freaking important because if you don't acknowledge that this is the case, you will not understand the importance of this statement. In short, when I twice my diameter, my area increases by 4 times because it's a pi r square. So if you think, oh, twice the diameter, oh, my area times 2, whole thing wrong already. You get it? So resistivity, yes, is based on the material, length is length. But today, if I even manage to change something, right, and that one thing, right, happens to be this, is worth it already. Because I save you about 2, 3 marks. So what I'm telling you is this area, it works in combined physics. Combined physics, they will give you area. Then they just change the area. Very easy. You just do your calculation. But when it comes to pure, they are not going to be so kind to give you area. They will tell you I changed the diameter. I half the diameter. And you need to understand the change to the area is by a factor of square. And that is how you go on to calculate how it changes your resistance. Okay, so for the second wire, even though I twice my diameter, my calculation will look like that. It's now pi bracket 2r squared, which is equivalent to 4 times the original area. Right? So when you do your calculation, it's a divided by 4. Okay, the rest of the minute calculation, I'm not going to care as much, but I need you all to know what I'm talking about. Can? Yeah, rho is resistivity, L is length. But the area is the area that y'all will go wrong. Okay, can? So please take care of this guy. Promise me, So tomorrow, if you see this question twice the diameter, you're like, oh bro, I got this. Okay. So please don't make the mistake here. Okay, definition of EMF, calculation. Unfortunately, I'm gonna skip a couple of this because this is not my key focus. Um, Here's the thing, you are likely to be, you will not be tested on how to define Ohm's law. The definition of Ohm's law is not required, but you are supposed to know what Ohm's law is and be able to analyze from a current against potential difference graph how the resistance is changing. Okay, so state what happens to the resistance of R and L as voltage increase. So over here, right, you need to understand that largely if you have a straight line means resistance constant. If you have a curved line, right, it means that ultimately your resistance is changing. Whether increase or decrease, you need to analyze how the ratio of your V over I is changing. Now, one thing that I am a bit more hesitant with this answer key is because I plucked this out from the publisher, but I'm not a very big fan of using gradient to explain how it's related to resistance. Technically, they are not wrong, but personally, if you're my own student, you will know I always emphasize this. The best way to define voltage resistance is V over I, ratio of potential difference over current. So you talk about how the ratio is changing to justify how your resistance is changing. Okay, my own students, you all should know what I'm talking about. But for the rest that has no idea, I'm just saying that I don't really like to use gradient. Reasoning is because gradient is dy over dx. Okay, y over x is different from dy over dx. But enough said, because that's overcomplicating things, I personally just like to use the ratio of v over I to talk about what is happening to the resistance. Okay, so even though I leave this as the answer, it's not my favorite answer key. Okay, but let's just leave it as that. I want to move on to the later half. Okay, conceptually, right, I'm afraid that some of you only memorize your potential divider formula and you don't actually know how it works. So in case nobody ever taught you how a potential divider work, a potential divider is just about dividing the potential difference. Based on this and this, the values, you would split the voltage up between the two. So if something has more resistance, since V equals to IR, something with more resistance will receive more voltage. So what happens, right, when the resistance of the variable resistor decrease? So if your value of R here decrease, your V value here will decrease. Even though my resistance did not change, this 6 volt must split between the 600 ohm and the variable resistor. So if your variable resistor receives lesser voltage, your 600 ohm will receive more voltage as a result because it's about the split between the two. So how do you divide the 6 volt between your fixed and variable resistor? That's how you calculate and that's how you conceptualize it. Okay. Yes, at the end of the day, you might need to use certain formulas to calculate, but all it's saying here, right, is that if I have 6 volt and I need to split it between something that has 600 ohm fixed versus 800 ohm, how do I split it? Right? I'll split it that this one gets 2.6 volt, this gets 3.4 volt. And this is according to a ratio of 600 to 800, or you can also read it as a ratio of 3:4. Can? So it's just really about a case of finding the ratio between the resistors. Okay, sketching becomes quite common. By the end of the day, it must add up perfectly to 6. All right, so I know some of you, when it comes to sketching, you get very fearful, but the total EMF cannot change. So you can therefore use one value to predict the other value as well. Okay, this question is quite cute. If anything, I'm going to address it quickly because a lot of you go like P and Q, huh? In what two ways are they different? It is the distance to the line that is different. The closer you are to the line, right, the stronger it will be. Right? So the strength of the magnetic field is actually weaker at Q than P because P is closer. All right. And because of this, when we do right hand grip rule, right, the direction of current will be different as current is supposed to be flowing from P to Q. Like that. Okay. So pay attention to this portion over here because a lot of people don't actually pay attention to the minute detail. The closer you are to the line, the stronger it will be. Okay. Now, this is the part that I know it's getting a bit like it's about nine already, but I have to address this properly. When we talk about Fleming's left hand rule, right, I need you all to be clear when to use it. Okay, there are two instances. If the question is phrased as describe how you manage to get the force, your job is to describe physically how you apply your Fleming's left hand rule, right? Which is your father, mother, child, right? Which finger represents which and how you point it. How did you get the force? How I did it was by using Fleming's left hand rule to guide me to finally get that force that I'm looking for. But if it's a question on DC motor, skip a bit. DC motor. Look at this. Describe how you determine the force. What do we bring up? We bring up Fleming's left hand rule. What is my index finger? What's my middle finger? What's my thumb? Describe how. Okay. But if they're asking you to explain, right? Explain, tell me why the thing is turning. Why? Not how. Why is it turning? It's really a case about explaining how there's an interaction between the magnetic field producing a force. Okay, this is not the best example because it's about the split ring commutator. Let me see if I have a better example. Wait. Okay, I don't have the exact question, but I hope you guys can follow me, right? Describe how is really about telling you about using Fleming's left hand rule. If the question says explain why the coil rotates, then you have to talk about the interaction between two magnetic fields. Okay, if you guys don't mind, you give me 1 minute. Let me pull out a sample question because I'm a bit worried that you guys don't get what I'm saying. Because this one, if it appears tomorrow, right? One GG already, I tell you. So many of you gonna get wrong. Or am I too harsh? Maybe you guys know your stuff. Wait, Once again, describe how you want to talk about Fleming's left hand rule. Let me see the one. Wait, let me find a good one. Don't have. Sorry, you give me a bit of time. I find a good question to explain. Draw the hair, not really. I don't think it's necessary. So I'm just going through some of my own worksheets to see if I can find a good question. If I can't, then I will give up. But until then, let me give it a bit of a try. I think it's worth looking for it. Don't have, unfortunately. Okay. Let me go over to the notes to see if I can pull it up. Okay, last part, wait, electro. Okay, I'll just use this part, all right? So if you want to be able to understand the key difference, right? You see this part over here in the notes, whereby we talk about how there's a interaction with the magnetic field of the permanent magnet with the magnetic field of the wire. This is how you explain why there's a force produced on the coil, one side upwards, one side downwards, to cause a clockwise or anti-clockwise movement. So the question is explain why. It must have this phrasing that I've highlighted here in yellow. But if the question is describe how, you describe Fleming's left hand rule. So you're not just supposed to blindly just jump in Fleming's left hand rule all the time. Okay? Can? Okay, circuit breaker, please make sure you go and read up and understand how it works. Could be tested quite often. For magnetism here, I'll move on. Not super important. Describe how, yes, this one, this one. Okay, so I need you all to be ready. If they ask you to explain how the split ring commutator ensures that rotation continues, this is very common. All right, so the wording that I'm looking for, right, is that current changes direction every half a rotation or half a turn, right? So that the side of the coil will constantly experience upward downwards, left or right side will experience the downward and therefore rotate in the same direction. Okay, so two parts to DC motor. Please be clear on when it's described how, Fleming's left-hand rule, versus explain why, which is the interaction between the magnetic field, and being very confident when they test you on split ring commutator. All right, so this part is a must know. Okay, other questions when it comes to your EMI chapter, electromagnetic induction, be ready for two main application. Your AC generator, sorry, three. AC generator, transformer, and dynamo. These three are the most commonly tested one. What you see over here is a version of an AC generator where the rotating magnet will cause a change in magnetic flux. So this one was in the 2015 paper. All right. Please understand if they ask you to explain why a EMF is induced, this is commonly associated with Faraday's law. All right. Change in magnetic flux. Some schools I know they insist on adding in the word linkage. Sure, same thing, producing an induced EMF. Okay. So this one, just make sure you know what's going on and how to explain it. And the moment you see, right, the word direction, why is the current in this specific direction? It is then Lenz's law. So for those of you who are very confused, like when do I use Faraday's law? When do I use Lenz's law? Faraday's law is used if you need to talk about why is there a EMF generated? Why is there induced current? How did it come about to be like that? Explain why. Why is it like that? But if they ask you to tell you to explain, it describe how you know the current is in a certain direction. Then it's about Lenz's law. It's about opposing the change producing it. So even though we learn both, doesn't mean we every time we just jump and we like write both laws. You're supposed to use the correct law in the correct situation, right? So please know the difference between Faraday's and Lenz's law. And then when you explain it correctly, then you'll be fine. Now, it's good if you are able to state the law before you go and explain it. But most of the time, it is acceptable that you talk about using Faraday's or Lenz directly. It's kind of like implied. Yes, okay, if you all take a look at what Trisha typed, exactly what I'm talking about, right? Why EMF generated Faraday's? Current in a certain direction, Lenz's law. Exactly. So you must know when to use which law. Otherwise, right, you will not get the mark. Right, so over here, you also need to be ready for any transformer questions. So transformer question means you need to know how to explain the change in magnetic flux in your primary, causing a change in magnetic flux in the secondary coil. I think that is very important, right? And how the soft iron core helps to concentrate the magnetic field. In terms of calculation, you'll be expected to know how to calculate based on the number of turns in your secondary and primary and how that affects your voltage and therefore your current. Okay, there are also instances at O level where they say, oh, efficiency. Not all of the power input on the primary goes to the power output in the secondary. So the difference in the value is the efficiency itself. Sometimes they will give you the efficiency and you calculate the output. Or in this case, they can ask you to find out what the efficiency is. By right, if your transformer is 100% efficient, your power in your primary should be the same as your power in your secondary. The difference is due to any version of energy lost or transferred to the surrounding stock. Okay. I will not stop here. Sorry, yeah. Efficiency is always a percentage, if you're wondering. There was a request for me to talk a little about radioactivity because apparently everybody is damn jialat at it. So what the Overmark physics department has done was that we compiled most of the latest prelim questions across different schools, and we came out with a worksheet lah. So my own students, you all should have this worksheet, the soft copy. So the main thing, right, maybe what I can do here to wrap up the final portion for radioactivity is what do you need to prepare yourself for? Okay, I won't have time to go through the questions, but what do you need to get ready when it comes to this chapter in radioactivity? First thing, do you clearly know what's the difference between your alpha, beta, and gamma particles? If you don't, you cannot do all of the basic calculations when it comes to questions. Now, I start with this one. A very simple question. We go through it together. This is particle X. Now, what is alpha particle? Alpha particle is your helium nucleus, 4, 2. Your beta particle is your electron, 0 minus 1. So when you emit this, right, it's saying that it's two of this plus one of this. So if you take a look at the value, right, 125, you need to minus 2 times 4. So that's how you get 117. What about 40? 40 minus 2 times 2 minus 1. That is a plus 1. So when you emit the electron, right, actually your number of electron here actually increases. So for those of you who don't get it, right, the math, right, for this 40 here is 40 minus 2 times 2 plus minus 1. Okay, so this is 40 minus 4 minus is plus 1. That's how you get the 37 here. All right, so I think this minus tends to confuse a lot of people. So please understand, if you emit an electron, your composition here actually increases. All right, the next question type that is the most common is half-life. So if you are still not confident for half-life, please go and revisit the questions again. So if a half-life is 5 days, meaning 20 days means you have gone through 4 half-life. So if your initial mass is 128, right? Doing a half-life 4 times means I divide by 2. This is 64. I'll divide by 2 again. All right, this becomes 32. Wait. I make sure I do it correctly. So this is 2 half-life already. I'll need to half-life again. This becomes 16. Sorry, don't enable the AI thingy because it's gonna slow down the recording. So can you see after 20 days, 20 days is the equivalent to 4 half-life. 1, 2, 3, 4. I know there's a formula for half-life, but I'm not a super big fan of it because it tends to confuse a lot of us. So my thought is that 5 days, 20 days, 4 half-life, I divide by 2 4 times. I'll get my answer. Can? All right. So this is the part that I need you all to be careful about because half-life will appear. All right. Then alpha, beta, gamma is penetrating ability is important. Uh, There's one more, which is the background count. Background count, right? For those of you who are not familiar, this means that even without any radioactivity material, I will still detect a value of 10 because all objects emits radiation. But it's only when you place it near a radioactive source that you see the value increase to 650. This means that the radioactive source is only responsible for 640. So you actually take the 640, half-life 8 minutes, 32 minutes means I divide by how many times? 4 times. So 640 divide by 2, divide by 2, divide by 2, divide by 2. That final value that you get right, you need to remember to plus back in the background count. Because background count is always present, even after half-life. So when you see background count, you need to be very careful because it means you subtract it to find out how much is the radioactive source. After the radioactive source finishes its half-life, you plus back in the background count to get the final answer. So this is 320, 160, 80. This is 40. So my radioactive source after 4 half-lives reaches a value of 40, plus back in the background count to get your overall count rate by your detector. You get what I mean? So background count is always present. You can remove it for calculation. You add back in at the end. All right. So other than that, what kind of other kind of questions can you expect, right? Nuclear decay will require you all to write equations. This is a very common question type. There are honestly many different scenarios. The scary part is honestly the fact that it has never been tested before, so we cannot really gauge how difficult or easy O level will set it. All right. But for my own students, if y'all can go through this paper, I think it'll be very good to make sure that you all get the exposure. I think it's quite important for you all to be able to articulate the effect of radiation. Keyword is ionizing, damaging the tissues and cells. All right, this one is something that is in your syllabus that you should know. Earlier, I saw somebody asking me about what's the formula for half-life. Is right over here. You should be able to find it in your school notes or your tuition notes. Cannot be, they never write the half-life equation. Okay, so N is equals to bracket 1 over 2, close bracket N. Refers to the number of half-life here. So how many times do you divide it by 2 in short? Okay, so this one I make sure you all know. What else? Let me see anything important. The ability to read the graph, all right, to know how to calculate the decay. This one I think is fine. Anything else important because I'm highlighting key facts. Likely they'll give you some version of information. All right. There's also a part I understand about nuclear fusion and nuclear fission, but nuclear fusion and nuclear fission is simplified, right, to be talking about how fission means I break it up. It's the splitting of a nucleus into two smaller atoms, while the term nuclear fusion means I combine two things together to release energy. In comparison, nuclear fusion is a lot stronger than nuclear fission. For those who are well versed with history, your atomic bomb is nuclear fission. Okay? Nuclear fusion is actually how the sun produces energy. So you can imagine, is sun stronger or atomic bomb stronger? Obviously the sun, right? Because it gives us so much energy to sustain life. So that is nuclear fusion. The most common thing they fuse is typically two hydrogen together. Yeah, so that is another way to look at things. Okay, so my own students, please go and spend some time to go and do this worksheet, okay? Because these are all the latest prelim questions. For the rest, I'm just scrolling through so you guys know. The isotope definition is the same definition that you can use in chem. Okay, I know chem is over already, doesn't mean you'll return your knowledge. So if you need to define the term of isotope, you can safely use back the exact same definition that you use in chemistry. Okay, so if you ask me to predict, I'll tell you guys this. Most likely, what you'll be tested on for radioactivity is likely, your three particle, the equation, maybe a bit on the penetrating power, but more likely, I think it's about half-life. Because most schools for prelim tested half-life. Okay, and just remember the part on the background count. That is usually where people tend to not understand what is going on. Okay, and a few things such as the definition as well as the dangers of radioactivity in terms of the ionizing portion. So those are the things that you need to study. Okay, if you stayed till this point, really, really thanks for pulling through. I genuinely hope that my sharing tonight helped to refocus a little bit on avoiding key mistakes that you might make tomorrow, knowing where the focus of your attention should be for the rest of tonight and tomorrow morning. At the end of the day, when it comes to physics, just know this, that every single question boils back down to a certain concept as well as a certain formula, right? The worst thing that you can do to yourself is that you completely give up on the question. Why? Because you say, oh, I do not know anything. No, every single thing you have learned it before, you just need to trust yourself and write your best guess answer. When it comes to physics, I genuinely feel it's about being careful. I think the units are the things that will kill you. If you're aiming for A1 and you're wondering why by the time it comes to your O level result, you get A2, it's likely your units. Light ray never draw in normal, use the wrong values, never include the keywords, not understanding the difference between describe how and explain why for static or for DC motor. So a lot of the things that will be tested is quite standard. So I want you all to go into tomorrow's exam with a sense of confidence that you just need to apply your concepts. The only thing you probably want to be revising a little bit more are your definitions. Because those usually will appear like 2 to 3 marks at most. But those are the marks that you can safely secure. Okay. Other than that, please rest early. I genuinely wish all of you the best of luck for the physics paper tomorrow. So I think it's really just a case of like trusting yourself, right? Just trust that all of the effort and hard work that you have put in will pay off. All right. If you still have a bit of time, I suggest you go and look back of all the different kind of questions that you have done recently for your yearly paper or for your prelim, and go and look through again and see what were the mistakes that you make. And promise yourself, right, that you will not make those mistakes again. Right. Otherwise, I'll process this. I will upload the recording onto YouTube for those that want to revisit us. Otherwise, I think that's about it. There's a request to show the bunny. Yeah, I can show you my background. Okay, I'm just chilling here already, because like we are officially done. So I'm back at the center. So we have a lot of soft toys at the center. Yeah. Can if not, that's really about it. All right. I need y'all to go into tomorrow's exam feeling confident. All right. For my own students, trust that the work that we have done will pay off. Okay, and that all the hard work, right, that we have put in day by day, okay, will materialize.